Hello? I'm hoping this is actually working. This is my first time using OBS. So here we can see a lambda expression. This is going to be explained in a moment. Now, if you don't know what the heck you're looking at, that's fine. I'm sorry I have a bit of a squeaky, creaky mic. But this is actually something that I'm working on, that I decided to record the process of working on with you, the public. So And I'm doing this all off the top of my head, so sorry if there's a little bit of awkwardness. Also, I can't just type the lambda symbol because for some reason Paint 3D is super finicky about that. Anyway, let's start from the top. This, in lambda calculus, equals true. Okay? Now, this, well, not in lambda calculus, excuse me, I'll explain that in a moment. But in what's called church Boolean, it equals true. Okay? Oh, don't want that capital. So this in church Boolean, just had to think to make sure I got that right. I'm a little nervous. In lambda calculus, this equals false. Okay? Now, a typical church Boolean, meaning like, so the guy who made lambda calculus, his name was Alonzo Church. So this is lambda calculus's way of showing Boolean algebra, which, if you're familiar, cool. If you're not, Boolean algebra is like a, how to put it? It's a thing of logic. All right. So we'll get into that later, but in a couple of different videos on my channel. But so typically, true and false in this go into this. Okay, so that's lambda p, lambda q, and then like p p q is the or capital or gate in if I remember rightly, that's the or gate in church Boolean. Okay, now the one I'm most familiar with is, hold on, PQP, which is the and crap gate. So if you'll notice, this right here has a similarity to this right here, right? And this right here, and this here, does something. And I'll explain all of this in a moment, as best as I can. Like I said, I'm a little nervous. But this is what we're going to be getting at soon enough. So the way that lambda calculus works, if we can just shrink this, just make that tiny, it'll be fine. So the way that lambda calculus works, and we'll show this with, hold on, my ear's itchy. That's going to happen a lot, I'm sorry. My headset's a little, it's not the best. So how do I want to show this? Well, I've recently been screwing around with representing uh, lambda in general without linguistics, like without this symbol stuff. I kind of want to show it here just to test it out, but come to think of it, it's probably best if we start off with the basics. So let's get this text field up here. And let's just work out how this thing right here works. Ah, crap. How this thing that we're calling true works. Yeah. Well, why is it true? What's so true about this? What's the truthiness of it? Okay. Well, to get to that, let's explain how. Probably want to fill that in. Yeah, we'll pretend that a gate is like a black box, right? Now in Boolean, this is the part that a lot of people are familiar with. So let's say that we have an AND gate, right? We'll pretend that this little square here is an AND gate. Now what happens is that you've got one. Ah, ah. That's the wrong tool anyway. Let's use this. Yeah, nice and clean edges there. So let's say, let's make it a different color so that it's kind of contrasty. So let's make 0 red. That's real intuitive, right? And let's make 1 blue, right? So we've got 0 on the top and, oh crap. So we've got 0 on the top and 1 on the bottom, right? Let's just, there we go. Clean that up a little bit. Excellent. So say we have these going into this AND gate here, right? Now what an AND gate does, what I'm about to show you is called a truth table. The thing about an AND gate, the reason why it's called an AND gate, what it will do is, let's TF uh how to represent this. We'll just do it a normal truth table. So what it'll do is it'll take T or F, which in Boolean, whoa, I don't want that. In Boolean, 0, right? And this is all a little complicated, don't worry. Just let it kind of like get into your noggin without overthinking it too much, right? Just accept as an axiom without further explanation that 0 equals false equals off, right? And 1 equals true, not not tire, true equals on. Okay? So just without any further consideration, just take this as gospel truth. All right? This is how it works. Because this gets into really complicated stuff, and it's not really worth bothering with right now. It's not really germane to what we're doing here. So red is false, T is true, and the reason why it's called an AND gate is because you'll have these values pass through it, right? And will come out on the other side. Let's go ahead and empty that box out. We're going to show what's going on in here, okay? Sort of. That's a little sloppy, but whatever. It's called this because these values will go through it, right? And something happens in this box that we'll be investigating in a moment as part of this video. But something happens in here. Big think, big question mark think. And according to what the logic of the gate is, will alter or process or whatever you want to call it. It'll compute this into an output. Now an AND gate is called an AND gate. That is the wrong color. Way to spoil it, I guess. But what an AND gate will do is output false unless both inputs are true. Now the thing is that Boolean algebra is binary. It is not actually anything other than binary. You can have generalized, I think is the right term for it, Boolean, where you have multi-input gates. But the sad, horrible thing is that it's still binary. Generalized is just like it's kind of like this is a little bit difficult to explain in a short way, but generalized is basically you can think of it one of two ways. It's either abstracted into like programming or such, or it's uh well, I'll show you, right? So if you have a bunch of input, you can have just I know this may sound strange, but you can just have a bunch of AND gates, right? Like you don't there's not really a limit on how many AND gates you can have, right? So what do you think happens if you have two AND gates next to each other that both feed into the same next AND gate, right? Well, as you can see, you basically just have a big AND gate, right? Like if all three of these are AND gates, let's get that out of there. But if all three of these are AND gates, naturally you're just having two AND gates feed into an AND gate, so you're only going to have this function according to its upstream functions. So that's the other way that you generalize, at least as I understand it. Boolean gates, right? So with that all said, it's called an AND gate because, right, it has to be 1 and 1. Clever, isn't it? It has to be 1 and 1, right? Now an OR gate, if you believe it, is not it does not actually involve rowing nor any nautical themes. An OR gate is called that. Why? Well, it's because if either or I'm so bad at this. It's because I'm under pressure. Such pressure. It's because if either or of these, right, is true, it comes out true. Now again, in here it's like, well, what is going on? This is kind of a black box, right? Well, remember our setup here, right, in our tiny instructive corner. This equals an OR gate. Now we gotta get into Boolean as represented by lambda calculus. So church Boolean is a very particular kind of, I guess you could almost call it like a rule set for lambda calculus operations. Now, if you don't know what lambda calculus is, don't worry. I have not spent that much time with it myself either. I'm going to teach you the way that I learned somewhat recently in my fascination with all of this. as part of what I do, um, my research and whatnot. So let's make all this tiny too. Yeah, just tinyize it. We don't need it anymore. Not right now. We can just have it as a reference. Okay. So now that that's nice and tiny, let's get back to this. So what is this? Well, in lambda calculus, do I still have... crud, no I don't. Well, we'll make do, right? Uh I'll show you what happens if you try to actually type out. Yeah, nothing happens, okay? So that's why we're screwed on that, but it's fine. We'll make do. So the thing here is that in lambda calculus, what these things do, these are called lambdas. Now you may be wondering, what does that do? And if you're wondering that, well, you're right to. It's a little complicated. So if we take this, go ahead and copy this. Now what this does, this lambda thing, let's unthicken that. Let's go with this, yeah. It is connected to this. Notice how this is the lambda x, right? It's paired up with this for a reason. This is lambda y. This is not y. This is x. Now you may be wondering, okay, well again, what does that mean? What does that mean at all, right? Now this is a little tricky to understand, and it tripped me up for an embarrassing amount of time. So I have full faith you, the viewer, will learn this faster than I did. But what it does is, say you put uh, f right over here, and I'll explain why it does this in a moment. But what we're looking at here, to give you the anatomy of what's going on. Oh, I didn't want red text. Well, actually, you know what? Maybe I did. Come to think of it. No, I didn't want text, actually. I'm just being dim. Hold on. Okay. So let's make these easy colors to look at, right? So this will represent one thing. This will represent another thing. Make it a different color. Okay, and we're just using these colors off the cuff. These might change meaning as we go, so don't be too worried about remembering this. I'm not going to remember it 5 minutes from now anyway, so it's fine. So what we're looking at here are three sections. Now, F typically, well, let's get started with the first part, yeah? What's on the blue is called the binders, right? They're the function. Maybe I should put that in a smaller font, yeah? Smaller font size. These are the function binders, right? I know that there's a couple of different names for them, but this is just how I remember them. So these are function binders. You know how I said this? Over here is illustrative of what that does. Well, what that is what's binding is the I'm forgetting the exact term, but I think of it as a variable, right? That's what x is. Now, there's other terms. Don't get mad, please. But I think of it as the variable. So what is f? F represents the argument. No, not that kind. Okay? So you may be wondering, okay, well, what kind of argument? Well, f in this is also a variable. Don't worry, it's not that confusing. All right? So the thing is, whenever you're dealing with an expression, right? At least for the purposes of what we're talking about here. The part that happens first, okay? The part that you're looking at first is this part, right? What's most important is to figure out, okay, what variables are mapped to what function binders in what is called the function body. All right. So what's going on here is we have a lambda x, lambda y, and x, and argument f. Now, what happens next is this. So that's what happens next, and then this turns into, well, hold on. That is sort of what happens next. I'm forgetting a crucial step. This is how those two relate to one another, but what actually happens next looks more like, hold on. That's a neat trick in Paint 3D, by the way. You can just undo all the way back and then copy and then redo and then paste your copy. I have like an enormous amount of hours in Paint 3D. I've picked up a couple tricks, thankfully. But what actually happens is that this, right? We're gonna need a wiggly line for this. So what happens is, that's a little too wiggly. Okay, I regret my decisions immensely. What this little guy will do, this little lambda, well, it's sitting next to x, and it goes, you know what? I go first because lambda is left associative, which just means it goes left to right. Okay? Now, the thing is, that's an oversimplification, actually. My bad. The order that it goes in, if you want to think of it as a turn order, is blue first, this second, directed at this third. Okay? And it goes left to right on both ends. So well, what happened here is that, well, I'll just use a capital A, right? Because the lambda kind of looks like a capital A. But what happens is that the lambda here wants to target the first thing from the left in the argument field. Okay? Because like I said, it goes 1, 2, 3, left to right. So what that means is that this will go and seek, no, this isn't, I've been playing too much Dark Souls 2, but it will seek F, right? Let's move this up a little bit. It'll seek F, and then what will happen from that is it'll find F, and once it finds F, like a homing missile, it'll collide into it, bonking it off kilter. No, it'll actually, what it'll do is it'll cause, or rather bind, uh, F to X. Now you may be wondering, what does that mean? Well, what do you mean it'll bind it to it? Well, what it means is, right, is that what you have next, if you'd believe it, is actually, let's get us a nice arrow going here. You know, I'll use the classic arrow, actually. Real big arrow. There we go. Is that what this turns into is, this. So, whoa. Okay. Blue. Purple. Yes, I know I have to think out loud for this to help myself remember what I'm doing. Sorry. And then get that nice earth brown color. Okay, so what will actually happen then is that you'll get this. Here we go. Yes. X has become F. And then you're left with lambda Y. Now, it doesn't stop here. Okay? It doesn't stop here. What happens next is that this lambda still fires. Let's compress that a little bit. Ah, crud. Ah, there we go. Yes, it doesn't stop here. What happens is still fires. But nothing happens. There's nothing there. But it still fires, which means that Y is actually bound. But there is no Y. So, dummy rocket. Basically, it missed. Now, what you're left with is just F. Now, whatever F was, right, whatever it was is what is left. So, you're just left with F. Because lambda tries to reduce to what is called if I remember correctly, a normal form, which is a fancy way of saying there's nothing else to do, right? So that's lambda, sort of in a very basic as I can get it anyway. Let's try to minimize that. That's the most basic version of it. And the reason why we're going over the most basic version of it is because it has to do all of this with what I'm actually trying to make understandable for whoever might be coming across my channel, i.e. you. So let's tinyfy that. Move this over here, okay? With everything else that we have tinyfied. So, we are back at where we started. What does this do? Well, we now know what it does. It gives, or rather transfers, or whatever, identity, value, whatever word you want to use for it, from arguments to variables within the function body. Alright? And it does this to whatever it is how to put it, like buddied up with. So if you see lambda as lambda x, that means that lambda is going to fire the harpoon to give an identity to x. obviously in reduction order or whatever you call it, left to right. Okay? So what this means is that whenever you're doing, right, like, goodness. Let's just do this the totally cool, totally not unprepared way. Just put those there. Put this right here. And pretend that that's, well, hold on. I don't like that stray pixel. Get rid of that. Anyway. So if you see this itself as an entity is a function. If I'm, again, remembering correctly. Look, I don't have the best memory, alright? I don't really remember these things as terms. I remember them for what they do. So, function. Please, no bully. And this function equals true. Okay? It is a function that takes the first argument and discards the second. And that's it. Now, why is that true? Uh, okay, that's kind of like asking, what is green? I mean, I'm not sure I really have a satisfactory answer for that myself, but it just is what it is, alright? It's true because it's a function that takes the first argument and discards the second. It is a function that takes the first argument and discards the second, therefore it is true. Alright? Let's just, here. I'm sure someone who actually understands this stuff on like a granular level could tell you why, but as far as my needs are concerned, and hopefully yours, uh, this is a fully workable, fully acceptable, what is called a, crap, I forget what, uh, bivalent something or other. The funny double arrow. It is what it is. Okay? Now, that also means that this, right, as the thing that takes, oh, well, let's get rid of that little dot. The second argument equals false. Now, you may be wondering what I mean whenever I say it takes the second argument. Well, here's the thing. Let's get a copy of this so that I don't have to finagle too much here. I don't have to worry too much about presentation. Sorry, my ears keep getting itchy. I know it's a little annoying, but... And yeah, this is going to be kind of a long video. Sorry about that. But what was the right? Blue, purple, brown. Okay. So let's get our blue. Let's get our. Well, this is probably. I don't want to just paint tool that because in MS. I was gonna say MS Paint 3D. That's a little gnarly, you know. But in Paint 3D, whenever you do the paint can tool on something, it adds this really ugly dithering effect. It just bothers me. I don't like it. So here's the thing, right? Yeah, and it doesn't take the second argument. I'm stupid. I shouldn't have said that. But well, it kind of okay. It does, but you'll see what I mean. Why I'm getting a little flustered here whenever I explain this. That dithering effect. I hate that so much. Okay, so let's get this down here where it belongs. In the nice cool blue. The ocean blue of function stuff. Now let's start off with just F. Like we did before, right? Now this time it is the AX. Well, that's how I think of it. It's the lambda X. I'm gonna do that more than once because I just think of it as an A. I just think of it as an A. Honestly, I can't really rid myself of that association. It's just not really something I can do. So we do this, get our nice big missile launch, our logic missile launch, harpoon, missile harpoon, like something out of Lost Planet. So here, that's way too light. Here we go. Now it's going to seek F. And boy, it'll get F. It'll find F. But the problem is, as before, whoops, there's no F. Rather, no X. Launch failed. Do not pass go. Do not deliver identity. So it just shoots off into the ether. Yeah, it's gone. And what you're left with is just this. Now the thing is, point point to be made. This is the identity function in alpha equivalence, which just means that let me build it from scratch here. Which just means it is equivalent in form, function, whatever. It does the same thing, right? So this right here is the identity function. This is also the identity function. You're left with the identity function, right? So the thing is that this is where things get a little tricky this still fires, right? And guess what? Launch failed. Do not pass go. So then what you're really left with is just this, which as an unidentified variable isn't really anything. It's like whole. It doesn't really exist. So here's the weird thing, right? So say we turn back time. Let's just get rid of all that. Let's let's avoid that horrible fate in which we are left with a thing that doesn't exist, right? And an identity function that doesn't actually return an identity. Let's pretend that gnarly awfulness didn't happen. And instead, we don't just have f, but we have uh t or t, right? We have ft. Now this goes off and misses when it tries to target f. Because as you know, there is no x. Ah, there is no x. But what you're left with is then this as the next stage, right? So something can still happen here. We're not out of the woods yet. We still have t. There's still hope, right? So this will instead, now that we are in the second stage, it will, this arrow ain't great, but this arrow's kind of seen the end of its usefulness, I think. It'll seek t. Here, let's just enlargify that and tinyfy this. So it'll seek t, right? Now the thing is, there is a y. So success. What happens next is we now have uh, whatever t was as the final product. Okay? Now, what these stages are called is called beta reduction. We are reducing the complexity of what is here, right? And the thing is, if you'll notice, is that with these two, right, It selected the second argument and bound it within the function body. So that is why it is false. Okay? Let's tinyfy all of this. Put it over here. Perfect. Excellent. So let's, oh, right, I already had one over here. Excellent. Super excellent. I forgot I did that. That's awesome. So this is the second uh, of two. Ah, because it's binary, right? Of the, whatever you'd call them, the signals, whatever, function, whatever. The thing that matters is it equals false. Now, again, what it is, like in its morphology, if you will, in its actual function, no pun intended, is that it is a function that takes the second argument and discards the first. And that's it. That's what false is. Okay? I don't know how long this recording has gone on for, but we're going to get all the way through, darn it. So that's what lambda does. That's what the little lambda does. That's what these do. So you may be wondering, okay, what the heck does that have to do with this crap over here? Well, why have we just taken that entire journey all the way through to now? And if you're wondering that, well, I don't blame you. I'm getting there, I promise. Let's tinyfy this and put it over here on the increasingly hard to read tiny noteboard. I don't know if I could even like untinify that. Yeah, no, there's no coming back from that. I hope you put a timestamp where you can remember where that was. There's no coming back from that tinyfication. Honey, I shrunk the tutorial. Alright. So let's get back to this AND gate. Yeah. Now that you've been shown what the basics are, the basic like units. Okay, this kind of needs some explaining. But whenever I said F, right, and T, you may be wondering, what are F and T, right? Well, I'm about to show you. So, if we look at this, let's copy and paste this back over here, because we're going to need them. Just like we're going to need a better, less blurry version of that. Holy crap. Okay. Copy, paste. Okay, so let's get our stuff going here. This is going to be a bit of a doozy to explain, but I'm here for it. I do still have the, yeah, excellent. Now there's some other stuff to explain with this, but we're just going to be getting right into the nitty-gritty. Okay? So remember, what we're looking at here is, same as before, the binder section, the function body, right? And the argument field works the same way. Now you may be wondering, wait, hold on. Hold the phone. Oh wow, yeah, like hold on. Was the big reveal that I purposefully matched F and T to true and false? No, I'm not that smart. I'm not really smart at all, folks. I did that purely by coincidence and am seriously amused right now. I only just realized that they matched. Did I really use F and T? Yeah, I did. Wow, holy crap. I did not do that consciously. I promise you I did not do that consciously. Wow. That works so well. Goodness. I'm a little impressed with my ability to do that subconsciously. But yes, it does, in fact, work exactly like that. Okay? Now, the problem is that if you want to view this in nightmare mode, here's what that would look like. Okay? I wish I could do the lambdas in the same color, but since I can't, yeah, I'll just go with this. So, so yeah, uh, I hope I got the parentheses right on that. Yeah, this is basically what it looks like. Let me be a little less lazy about that. Yeah, that's kind of bad. Give that a little bit more breathing room. But yeah, this is what this looks like in nightmare mode. Okay, you don't actually want to try to do this way in your head. This ain't the best way to do it. All right. Whenever you're just starting to try to figure out how this stuff works, don't try to remember it like this. Okay, and it's not really all that helpful. Just remember that these do equal true and false. Okay? You do not have to remember it like this. And if you're wondering, yes, it is taking the parenthetical as a whole unit, which is why we just call them true and false instead of engaging in Cthuloid antics. Okay? Because if you want to make this in the simplest version possible, the above actually just reads as, if you would believe it, well, I guess that's not technically correct, but we'll need a different color for this. Okay, this technically just reads as and true false. How convenient is that? Right? And the way you can look at this is like, okay, this is just literally this. Okay? So we'll just line that up there, and then we'll just stretch the and all the way over like that, because that's literally what it is. That's it. Uh, yeah, whatever. Nah, that's a little too stretched. There we go. There we go. Actually, I don't want to do that. It's so finicky. There we go. That's what it actually is. Okay? That's what you're looking at. Now, the thing here is, it works exactly how you think it works if you are very unfortunate to immediately try to do that in your head as a novitiate who is not used to this. You are absolutely correct if you immediately went, okay, well, isn't that, doesn't this turn into, after the first stage of beta reduction, hold on, one moment. Like, doesn't this just turn into, after the very first stage, uh, well, first off, we need to copy this. And my OCD is kicking in. I cannot withstand it much longer. Hold on. Please hold. That one pixel. There. Okay. Now that my brain has finished tormenting me, like, doesn't that just turn into this? Don't worry, we're going to cut it down to size. It's fine. Wow, I almost got that, like, perfect. Goodness. Yeah, doesn't that just kind of, like, turn into this? And it does, but remember that how it actually looks in non-colorified stuff is how to put this, in non-chromatic language, it is like, and you know, it is a little ugly that I'm gonna have to do this, but yeah, how about I just put some parens there? We can do it the snazzy, snappy, quick way. So here's the thing. What this actually looks like in Cthuloid antics mode, in the same kind of mode that you're gonna be experiencing if you say, I don't know enough about Bloodborne to make eyes on the inside jokes, but you know, just roll with it. Yeah, I was about to, then I just realized I don't know crap about Bloodborne. But like, this is actually what this looks like in Cthulhu Vision. If you care to see Cthulhu Vision, because these are now nested within here. All right. Now the thing is, these don't have anything to bind to. They're in normal form. They're fully reduced. So there's no like doohickery going on with these, right? What will actually happen next is, because of that, because there's something that can be done outside of the nested parents, this, right, right here, is the argument that will be put into Q, which means that what it looks like next, again in Cthulhu Vision, will actually be this. And guess what? The reason why is that this lambda has dropped off. So this now becomes the left edge of the expression. And since it has dropped off, so too has its parent on the left. Its parent parentheses, you know, the thing keeping it nested. There's no reason for it to be nested anymore once this fires. So now what you're looking at, curiously, if I can remember which thing goes where correctly, instead of having a massive brain fart. So now what you're looking at is this in Cthulhu Vision, which is actually just true, false, true. Okay? Just to uncthulify that. Now, the thing about that is, now that we are no longer in Cthulhu mode, we unfortunately must immediately go back into Cthulhu mode, because what we're actually looking at here is this. Now, you may be wondering, wait, what? Yes. Now, what happens next is, if you believe it, this is the next stage. And, as before, I'm going to need a large box for that. Okay. Crap. I didn't want to do that. What we're going to want to do is make it obvious what's going on. Right? And by now you probably understand what's about to happen. So hopefully we can skip, if you don't mind, and if you are a little lost, it's okay. This isn't like this isn't stuff that's like easy to grasp. Like I said, I'm not like some guy who learned this at like college. All right, I'm not gonna begrudge anybody having a hard time following. It's totally fine and natural, and it's cool. But what I am going to do is skip. I can't let that uneven bordering remain. Okay, there. I'm out of the woods of having a intercranial pressure event. So yeah, so we're now operating with this, right? And if you know, so we look at that's lambda x, lambda y x, false true. Now, from what we know, right? What does lambda do? It's a function that takes the first argument and discards the second, right? And we looked at that over here. Now remember, this still fires, just as this fired, right? So what that means is that even though there's only x, what happens next is, even whenever it reduces to this, right? Ah, crap, I don't have false on a, I guess I gotta actually type out crap. Just making sure I did this correctly because I got confused there for a second. Yes, I did it correctly up until this point. See, even I'm getting confused. I was like, wait a minute, was that supposed to be false in the middle? It's like, yes, of course. Yes, it's PQP. Duh. Duh. It's duh. So don't, like I said, don't feel bad. Okay? It's total. It's This is a very simple, relatively lambda, church Boolean whatever thing, and I'm getting confused. So it's totally fine. So what that reduces to is false, and that's normal. I don't know why I was having such trouble with that. I basically had a little mini brain fart there. Like, wait, hold on, what? Why is that false? Okay, let's put a little bit of distance between those, yeah. Section that off nice and clean again. I said nice and clean again. Now, we're still left with true. And as before, and as I've made a big showing of pointing out, this still fires, right? This still, after we're done being attacked by the blob, this still tries and successfully hits true over here, the second argument. But again, it knocks it out, knocks it off kilter. It falls into the wasteland below, and all that is left is false. Okay? So that's the full beta reduction steps for and true false. Okay? Including Cthulhu vision. To help you understand how this all works, if you're completely new to this and you just want to watch this video for some reason, that's the most exciting, actually, outcome of me recording any of this stuff, is that people get to learn this stuff, kind of how I did. So yeah, this is and true false, right? As stated over here, let's tinyfy that. Take our tinyfied accompanying graph, tinyfy it, and put it right under there. Okay. So with that all explained, hopefully you understand like the very basics of how this works. And I'll get into some more stuff next time. This has probably been a much longer recording than I planned on it being. Uh I actually need to check how long the recording is. So on the next one we'll get back to it.